All right, so this was by far the most missed problem. We spend the least amount of time on it in class. It's definitely the most abstract. It's also the most real world applicable. And in terms of what does real world math look like this actually comes up quite a bit in real world math applications, people who do math for a living. Um, but anyway, so the first part's not too hard. Describe the relationship between the hours. So the first thing is we're kind of envisioning a line of best fit. We can look at this data and it's a little all over the place, but at the same time, it kind of follows this line that sort of goes like this. Okay. And how will we describe that line? Well, first of all, is the line positive or negative? Well, it is. It is negative because as you read it left to right, it's going down. Okay, so first of all, we could say it's negative. The other thing we could say is it is linear. It's linear because it doesn't like curve down around. It doesn't like go up and then come back down. It does follow, generally speaking, a straight line. Okay, so it's negative, it's linear. That was part of it. The biggest part, though, and really the part I graded was, can we describe the relationship between the X and the Y? Hours per day on social media. So remember, you always start with your X because the hours is affecting the test score. How many hours you spend per day on social media, that's what's changing your test score, not the other way around. So as hours increase, what's happening to the test scores? Well, as these hours are going up, the test scores are going down, and that's why it's negative. So as hours increase, test scores are decreasing. So draw a line of best fit and calculate an estimate for the slope of this line. This is going to be different for everybody, and I don't want you to end up with the same thing that I have right here. The first step for this, I'm going to go through it quickly so that I don't take too much time with this. The first step is you need to find 2 points that are on your line. And the 2 points that I see immediately is this point right here and this point right here. Okay, it should be on the line. So some people pick like this point and this point. When you put a line between those, it's going to be a completely wrong thing. So, and then you're going to estimate those 2 points. So that I'm going to estimate this at about, let's just call it 3 on the X. And on the Y, it's between 80 and 90, so let's call it 85. Okay. Same thing for this one. Okay, you're estimating 5. It's halfway between 5 and 6, so let's call it 5.5. And again, does not matter if you said 5 or 6. It just needs to be close. It's between 60 and 70. Let's call it 68, just to make this interesting. It's a little bit less than 70. Okay, so there's your 2 points. And all you need to do is find the slope. Okay, and to do that, you're going to use the slope formula that we talked about. Okay, remember, we know that slope is our change in y over change in x. But what happens when you can't just see the change? If it's 1 to 2, we know the change was 1. That's easy. If you can't see the change, you subtract. So you're going to take your first y and you're going to subtract the other y. You're to find the change in the x, you're just subtracting. So x2 minus x1. That's where that formula comes from. It's just calculating that change. So literally we're thinking, well, from 85 to 68. Okay, you're going to go backwards to actually plug this in. So 68 minus 85. Okay, over, well, from 3 to 5.5, we're going to go backwards. 5.5 minus 3. Make sure if you started with the 68, you had to go to 85, and then 5.5, you had to go to 3. You have to start with the same set both times. Okay, I have my calculator right here. Let me do this real quick. So we're just going to subtract 68 minus 85 gives me negative 17. And you'll get something close to this, but shouldn't be exactly the same. 5.5 minus 3 is going to give me over 2.5. So we're going to calculate this negative 17 divided by 2.5. And it's going to be somewhere around negative 10. I got negative 6.8. Okay, so you should have something around negative 10. People have different things. This is what I got. You should not have the exact same thing as I do because you should have 2 different points. But I did keep it as the same problem. So this is the most missed problem, and all you had to do was estimate these points and just find the change in y and then find the change in x. That was it.